is we're looking at area of a sector. So we can find the area of a sector by equating the ratio of the area of the sector to the area of the whole circle and the ratio of its central angle to a whole revolution. So what we do is we look at our area of a sector over the area of a circle is equal to our angle, which is our theta, over the whole revolution. So I didn't really leave a space there, did I? Whole revolution. Okay, so what we have is for area of a sector, we're going to put an A because that's the formula that we are finding / using. Okay, area of a circle. Does anyone remember the area of a circle formula? Yeah, it is pi r squared. Amazing. Equals our theta, our angle theta over our whole revolution. So a whole revolution of a circle is how many degrees? 360, which equals 2 pi. So we're going to put our 2 pi there. Now what we do from here is we want to make our A the subject for this formula. So we multiply up our pi r squared. So we get A equals theta times pi r squared all over 2 pi. Now the only thing that we can cancel out here is our pi's. So they go away, and how we write our formula for the area of a sector is we write a half r squared theta. Okay, that is how it is written on our reference sheet. So we've just rearranged our theta r squared and divided by 2 to be A equals a half r squared theta. Okay, so that's finding the area of a sector. So that would be if we were to find the area of our piece of pizza or our piece of pie. Okay, that formula is on our reference sheet. So we never have to remember it. We just need to know how to use it. Okay, what we have is our theta is our central angle subtended by the arc, and remember that this is always measured in radians, okay? So we want to be working in radians, so that means that we want our calculator also to be in radians. Now, for our first example, what we have is we want to find the area of the sector with an angle of pi on 4 at the centre of a circle with radius of 5. So we have our angle of pi on 4, our radius of 5. So we're going to write those two pieces of information over on the side because they're the things that we're going to have to substitute or replace into our formula. What we then have is we want to write out our formula for area of a sector. So A equals a half r squared theta. And then we just substitute. So we'll have A equals a half times 5 squared times pi on 4. Now, generally we want to leave as an exact answer. So what that means is if you have the new calculator, the FX 8200, you would just put this all into your calculator, including the pi, and it would give you the answer of A equals 25 pi on 8, and our units are meters squared. Now, if you don't have the new calculator, on your calculator, what you would put in is you'd go a half times 5 squared times a quarter. That gets you your 25 on 8, and then you just input your pi at the end. Does that make sense? Okay, we always want to make sure that fraction is in its simplest form possible. Okay, and then we leave as, unless it's asked to so many decimal places, we want to leave it as exact. Okay, so our exact answer is always in terms of pi or a third. Cool, flip the page when you're ready for the next or the last two examples. So with our next example, we're going to do one where we have our radius and we're being given our area of our sector. Now, how we know we've been given our area of our sector for the next one is because we have centimetres squared next to our unit instead of just centimetres. And then we're going to have to find the angle in degrees at the centre of the circle. So the question reads, the area of a sector with our radius of 4 centimetres is that our area of our sector is 6 pi on 5 centimetres squared. Does that make sense? It's not telling us that that's our angle, it's telling us that that's our area. A lot of people get tripped up on that. What we want to do is we want to find the angle in degrees, okay, at the centre of the circle. So over to the side, I'm just going to write a list of what we've been given. We've been given R equals 4, A equals 6 pi on 5, and our theta is our question mark that we're trying to find. So we're going to start off with our A equals a half R squared theta, and we're going to replace our A with our 6 pi on 5 equals a half times our R is 4 squared times our theta. Okay, we're just going to tidy up our right-hand side before we do anything. So what we will have is 6 pi on 5 is equal to a half times 4 squared. Well, 4 squared is 16, and a half of 16 is 8. So we have 6 pi on 5 is equal to 8 theta. Now, theta is what we're trying to find. So because we're trying to find theta, we need to divide the 8 from both sides to get theta by itself. So in our calculators, we just put 6 pi on 5 divided by 8, and we get 6 pi over 40. If you have the old calculator, how you get to that is you go 6 on 5 divided by 8, which equals your 6 on 40, and then you just put your pi in. Okay, now we can simplify 6 pi on 40. Actually, your calculator should have pulled out as 3 pi on 20, because I haven't simplified that. I've just used my brain to do that one. Okay, and now we want to find our angle in degrees. So to get from radians to degrees, what we need to do is times by 180 on pi. Okay, how we can remember that is what we want to happen is we want those pi's to be cancelling out. Okay, so we want the pi's to be going away. So we need our pi. When we have radians, our pi is on our numerator. So to get rid of our radians, our pi is on our denominator of that fraction. Okay, this then gets that theta is equal to 27 degrees. Oops, sorry, when we put that into our calculator. Anyone got any questions about that one? No, we're good? Okay, example 3. With example 3, there's something missing in the question. I don't know how it disappeared, but the area of a sector is 25 pi on 6. I don't know if you guys have the pi there or if it's a little blank. You have the pi? Okay, it's just not come up online. So the area of the sector we've been given again, it is 25 pi on 6 centimetres squared. And we're told that the arc length is 5 pi on 3 centimetres. Okay, what we want to find is find the angle, okay, and the radius. Now, it doesn't tell you angle in degrees, so that means we want to find the angle in radians. So the pieces of information that we have for this question is we have that A equals 25 pi on 6, and we have our length, our arc length is 5 pi on 3, and we are trying to find out what theta is and what our radius is. There are 2 question marks that we're going to find. Now, we could start with either formula or either piece of information here, but since we're doing area of a sector and that's listed first, I'm just going to start there, but you could start with the arc length first if you'd like. So what we have with our area of our sector is it's A equals a half R squared theta. Okay, so what we have is we have 25 pi on 6 is equal to a half R squared theta. Okay, where we don't know what R or theta are. Now, I don't like that half at the moment. I just want my r squared theta. So what I'm going to do is I'm going to times both sides by that 2. So what I get when I do 25 pi on 6 times by 2, I get 25 pi on 3 is equal to r squared theta. Now, I definitely could rearrange that a little bit more, but I'm going to leave it like that for now, and I'm going to put a nice little 1 next to it. Now what I'm going to do is I'm going to look at my arc length formula. So my arc length formula from last lesson is L equals r theta. Remember, that is on your reference sheet. And then what we have is that our arc length is 5 pi on 3 equals r theta. Now this formula is a little bit more easier to rearrange and make something the subject. And I'm going to make theta the subject by dividing both sides by r. So what I will have is that theta equals 5 pi over 3r. And I'm going to call that equation 2. Because what I'm going to do now is I'm going to solve the simultaneous equations. So this is why it was so important back in topic 2 when we did equations and inequalities to make sure that we understand how to solve simultaneous equations. Okay, so to solve my simultaneous equations, what I'm going to do is I'm going to sub equation 2, because I've made something the subject in equation 2, into my equation 1. So what that means, wherever I have a theta in equation 1, I'm going to replace it with 5 pi over 3r. So what I will have is 25 pi over 3 is equal to r squared times 5 pi over 3r. Okay, all I've done is replace my theta in my first equation with 5 pi over 3r. Now, hopefully we can all see that we have r squared over r. So one of the r's on the top is going to cancel out with the r on the denominator. And so what happens there is we're left with 25 pi over 3 equals r times 5 pi on 3. Now, what we're trying to do here is we're trying to find out what r is. So in order to find r, we're going to get rid of that times by 5 pi on 3. So to get rid of that, we divide by 5 pi on 3. Now, all of your calculators should be able to handle this, but when we do this, we get r equals 25 pi on 3 divided by 5 pi on 3. We get that r equals 5. Okay. What we now want to do is we want to sub r equals 5 into equation 2, because now we want to find theta. And so when we sub r equals 5 into equation 2, we have theta equals 5 pi over 3 lots of 5. Okay, when I put that into my calculator, I get that theta is pi on 3. And so therefore, my radius is 5 centimeters and angle is pi on 3.